So, what we do is the following: when we encounter a nonlinear two port in a circuit, first we obtain the operating point by the usual painful way of solving any nonlinear equation. Okay. Once we have the operating point, things are easy. All we do is substitute the nonlinear two port with a linear two port, and what are the parameters of the two port? They are nothing but partial derivatives of the large signal characteristic at the operating point. And what is the circuit equivalent? In case of a one port network, the equivalent was a resistor. In case of a two port network, the equivalent is a linear two port. Okay. And what is that? We have our nonlinear two port. The equivalent of this is a linear two port. Sometimes you are just given the matrix inside the box, you know exactly what it means. If this is V1, I1, V2, I2, this will be delta V1, delta I1, delta V2 and delta I2. And the most important thing is, first of all, this is valid only for small increments, and this is evaluated at the relevant operating point. So, just like you calculate the small signal resistance of a diode at the desired operating point, you have to calculate all these parameters, these partial derivatives at the relevant operating point. Now, you can use this in equations. Usually, we find it more comfortable to work with circuit equivalents. So, the circuit equivalent of this also, you know, it will be on port 1, you will have a conductance Y11 or a resistance 1 over Y11. Okay. By the way, it must be pretty obvious that the dimensions of all these are conductances. That is clear from here. Okay. You have currents here and voltages there. You have to multiply the voltage by something to get a current. So, this has to be a conductance. So, do all four. Okay. And you will have a control source which will be Y12 delta V2, and on the other side we will have a control source which is Y21 delta V1 and a conductance Y22 or a resistance 1 over Y22. This is delta V2, this would be delta I2 and this would be delta I1. Okay. So, just like you replace a diode or a two terminal nonlinearity with a resistor, you will replace a two port with a linear two port. Okay. So, that is all that is there to it. Now, one more thing is, we know that, let me again take the example of a diode, or you could consider any other one port element or a two terminal element. We have the plot of current versus voltage, and we know that for a diode it is something like that. And let us say it is biased at a current, or the operating point current is 1 milliamp. We also know that the small signal incremental equivalent, what is it? It is a resistor. We know how to find the value of this resistor. This R will be basically, if the nonlinearity is F, R will be F prime the conductance G will be F prime at the operating point. Okay. So, that is you have 1 milliamp and it is the slope of this graph. What is it for a nonlinear element? As we saw earlier, a graphical depiction of a nonlinear characteristic requires 4 plots, I1 versus V1 with V2 as parameter. So, for these 2 plots, V2 is the parameter and for these 2 plots, V1 is the parameter. Now, we know that the incremental parameter y11 is nothing but dou f1 by dou v1 at the operating point. We need the slope of the curve I1 versus V1, which is in this graph at the operating point. Okay. And let us say the operating point is something. Okay. We will know what it is. Let me call it V1 0, V2 0. So, what you do? You look at where V1 0 is on this graph and you select the curve that corresponds to V2 0. Okay. And the slope of that at that point, that is equal to y11. Similarly, on this curve, we know that y21 is dou f2 by dou v1 at the operating point. You look at where v1 0 is, you pick the curve corresponding to v2 0 and the slope at that point equals y21. Similarly, these 2 graphs give you y12, which is the derivative of f1 with respect to v2 at the operating point. So, here you look at where v2 0 is, you pick the curve corresponding to v1 0, let us say it is this one, then the slope there equals y12 and finally y22 is the partial derivative of f2 with respect to v2 at the operating point. So, again you look at where v2 0 is, you pick the curve corresponding to v1 0. So, let us say it is that one, then the slope there, slope of that curve at the operating point, that is equal to y22. So, in general all small signal parameters are basically derivatives of the large signal curves. Okay. This I1 versus V1, these curves are known as large signal curves. It is large signal because it is not small signal. The small signal refers to small increments around the operating point, large signal refers to the total characteristics, and the small signal characteristics are derived from the large signal characteristics. The small signal linear parameters are basically slopes of the large signal characteristics at the operating point. This is true for 1 port, 2 port or any number of ports, any kind of nonlinearity. Okay.